So thanks to everyone for joining today and taking the time to jump into this webinar. My own name is Brian Fagan, and I'll be presenting and demonstrating the Fusion 360 CAM and machining extension for you all today. The plan over the next 45 minutes is as follows. I have a 10-minute presentation to run through, explaining who I am, what Fusion 360 is, and how we can get the best out of the CAM by making it even, or by upgrading to the machining extension. We'll then jump into a live demonstration where I'll showcase some of the cool functions and features that the machining extension has to offer, and how you can today can massively improve your machining process by lowering costs, improving quality, and decreasing machining times and programming times. So let's jump into the presentation. So just as I mentioned, my own name is Brian Fagan, and I'm based in County Limerick, which is located to the southwest of Ireland. As you can see from my bio on screen, I have a degree in manufacturing management, and I'm also a qualified toolmaker by trade. I have about 20 years experience in the manufacturing and designing world, from setting up CNC machines, programming CAM, designing jigs and fixtures, process improvement, pilot to commercial production, product transfer, setting up and implementing a workshop within a multinational, setting up and production lines, recruiting, training, upskilling for both departments. I joined Cemetery back in 2019 and joined the MFG team, the manufacturing team, adding my skills to the team to broaden our range of knowledge across design and manufacturing industry. So that is a little bit about myself. Just a brief on Fusion 360 for people that have joined today that still are possibly unaware of Fusion 360. I know most of you here today are interested in the machining side of Fusion 360. So what is Fusion 360? So it is a connected CAD/CAM platform that is cloud-based. So what does that mean? It would be like SolidWorks and Mastercam fusing together to create one software, meaning you just have one file that is your design, and that one file would also contain your CAM and your NC code, so which makes your life a hell of a lot easier, that if there was an upgrade or a new revision of that design, that your NC code or your CAM would also update with it. So if you added a fillet or a few holes or some extra features on your design, that when you switch into the CAM environment, it's just a matter of regenerating toolpaths, and it's all complete for you, saving a huge amount of time in programming. Whereas a disjointed CAD/CAM process would be, again, if you were to use SolidWorks Mastercam idea, it would be you'd do all your designing in SolidWorks, and when you've your design created, you'd export it out as a step file or an IGES file, and you'd send it across to your Mastercam. Then your programmer would set up their would write the program or generate the code and spend a couple of hours creating toolpaths and updating feeds and speeds and selecting tools and creating a program ready for your CNC machine. And then if the designer came back a couple of hours later and decided he forgot to add in one or two features, he gives you a brand new step file. Then you have to do the exact same procedure again, where you import that into Mastercam, set back up your datum, set up your XYZ axis, and rewrite all the tool paths and the strategies across that part again, causing a number of hours each and every single time there was a slight update done to the design. Fusion 360 is connected, meaning it removes that workflow, saving huge amount of time. So if somebody forgot to add a fillet on the part, it's no biggie. It's just go back into the manufacturing environment, update your as simple as a couple of clicks of the mouse, where you regenerate the toolpath, and it would take that fillet into consideration and then spit back out your NC code. So that's the beauty of Fusion 360. So that's just a teeny part of Fusion. So as I said, it's CAD/CAM platform. It's actually a huge amount more. It's a CAE, a PCB platform also. So you can create PCBs and you can do all your simulation, whether it's stress test or buckling tests or thermal analysis or flow analysis within Fusion 360. It does rendering, it does generative design, and you can do animations in order to be able to showcase how the part or design was assembled. So all within the one platform. So let's jump on to the next slide. So that is a little bit about Fusion 360. So why the machining extension? Why would somebody want the machining extension? Because when you buy Fusion 360, the base package comes with a certain amount of ability to cam your parts or to program your parts on CNC machines. The machining extension simplifies and automates the cam programming. So by purchasing the extension, you'll speed up automation, you'll reduce programming time, you'll reduce errors, you'll reduce machining time as well. So there's some of the benefits of the machining extension. So reducing cycle times and performs improvements, optimizes the manufacturing workflows, produce better quality parts, advanced strategies, better surface finish, and less manual finishing for better parts. So again, this all comes within the machining extension. So as I said, Fusion base, you can do a lot of cam programming with the base, but with the extension, it just gives you a lot more improved or better strategies or increased strategies to improve all of the points that we just pointed out. So there is actually 16 additional features that come with the machining extension, and they're all based around improving capability, improving your efficiency, and improving your quality. These are the 16 different features that or functions that come with the machining extension. So you can see there's a huge amount. The ones that I definitely find beneficial, and it's not just beneficial to 4 or 5 axis machine and or machines, they also benefit the 3 axis users also. So you can see there's a lot of 5 axis steep and shallow. The steep and shallow works in 3 axis as well. So steep and shallow is one of the major functions that comes with the machining extension. I'm actually going to focus in a little bit on the steep and shallow for a minute, because it's a strategy that I think the machining extensions worth getting for just this strategy alone. It was one of the first toolpaths we brought across from PowerMill. So PowerMill being the powerhouse of CAM for Autodesk. And with data and research at the time, we were told that it was the 5th most used strategy, the 3rd most commonly finishing strategy, and the top strategy from PowerMill, for which there was no like for like comparison inside Fusion 360. Steep and shallow is a single toolpath which can machine all the surfaces on complex 3D forms. It combines the strengths of traditional 3D finishing toolpaths by automatically detecting slopes and surfaces and applying the appropriate strategy for each region. The strategy has a huge amount of options for control to output, such as overlap distance, transitioning between regions, ability to finish, to choose a finishing strategy, enabling continuous passes, setting your step over, cut direction, all in one single location. It has additional options to improve surface finish, increase tool life, minimize transitional moves, adding wall clearance, which prevents tool marks being left on adjacent walls. For scallop passes, it smoothens sharp corners, improving machine motion, reducing dwell marks on finished parts. You can add corner cusps that will be removed with the remaining automatically detected and removed, further refining your final surface and minimizing the need for manual finishing or polishing. And lastly, the ability to machine large complex parts with automated collision avoidance ensures that you use the right tools for the right job to get the best outcome every time. So if I was just to pinpoint a few of the strategies here on that screen that we see here, the steep and shallow obviously is the one that I said I'd nearly buy the extension alone just for steep and shallow. But collision control, so that would be beneficial for when if you have a 5-axis simultaneous machine and the tool, you don't want to be pulling your tool out a certain distance, because the more the tool is sticking out of the collet or the holder, the more deflection, the more vibration that's going to be in that tool when it's running, meaning you're going to be left with vibration marks, etc. So what collision control does is you can still have a tight tool inside there, but the tool will alternate or it'll rotate in order for that holder to go down to certain pockets without having to pull that tool or have the reach of that tool. So it rotates the machine to allow that tool to be able to go into certain areas of your part. The blend strategy is another nice one to have. Automatic hole recognition. So again, if you had a part that had many different holes, like tapped holes, reamed holes, tapered holes, counterbore holes, the hole recognition finds everything on either 3-axis or 5-axis part, and you can apply by a couple of clicks, and it'll pick your spot drill, your taps, and it'll do all the heavy work for you. Again, saving huge amount of time on selecting holes individually, setting up your spot drills, setting up your drills, setting up your taps, counterbores, etc. The hole recognition does all of that work for you. So again, it just makes your workflow so much easier again, and getting that part to machine. Obviously, on every machine floor, what we don't want is machines sitting idle. Machines don't make money when they're sitting idle, so it's to get that speed from part to machine as quick as possible. So hole recognition is a huge advantage there that comes with the machining extension. Trimming the tool path, again, when we generate tool paths or strategies, we can see that sometimes there's areas that it's cutting air. We can actually trim out and we can cut tool paths out. So we're getting rid of all of this wasted time where the tool is just cutting fresh air at a certain feed rate, and it's wasting time. We can remove all of that with the extension as well. Move entry and exit position. So if your strategy, just because it automatically selects just a location to blend your tool in when it starts to cut, we can move them areas. So like that, if it was starting to cut on a wall surface, you may see a tiny bit of a mark from where the tool entered into the part. We can move that entry and exit position to maybe a corner where there's a fillet, where we don't care too much about where the little blend mark is. Again, having the extension will allow us to do that. So there's much more that the extension will give us as well. You can see there just probe geometry, surface inspection, automated part alignment if you're using Renishaw probes, etc. We can actually benefit from having all of them as well, that we can select the part. If the part was the billet was oversized or undersized, it'll line the part up each and every single time to get the center of the block, whether it's 100 or 105 mil, etc. So all of that available with the machining extension too. So we are going to just jump straight into a demo here. So I'm going to do some playing around with Fusion 360 and kind of showcase some of the nice features that we have with the machining extension. I'll create a part from scratch, not create a part, but I'll machine a part from scratch, just for the category of people that are on here today that have Fusion 360 and maybe not using it as a CAM package currently, to just showcase how user friendly or how simple it is to start creating tool paths for your CNC machines. So without further ado, we are going to just jump straight in here. Actually, before I do that, I just want to run a quick little poll. 1 second now, just to kind of get a bit of feedback. So let me just launch this poll. So if you just take a couple of minutes, and I'll let you all select the options here to see. I just want to kind of get an understanding of what we're using as our CAM package or our machining strategy. Just give it another couple of seconds. Okay, so I'm going to close that poll, and I can actually share that with you and showcase what we're seeing here. So we can see that Fusion is used a lot. So just over 50%. We've got other. I would like to know what the other products that are out there. I could only have 5 examples here on my poll, so I do apologize. So there is a chat box there at some stage of the webinar today. Maybe you could just pop Elate into the chat box what software you are using. I see a couple of Mastercam users as well. So let me just hide that there. Okay, so we're going to move on to the demo here. Just make sure you're all seeing what I'm seeing. Perfect. So we have a part here on screen. So again, I'm going to show a couple of nice tricks. So for the people that are using Fusion 360 already, maybe some features that or shortcuts or nice things that you may have not have already known. Possibly you know it already, but let me show you anyway. So we have a part here that we want to go ahead and machine. So at the moment we are in the design environment. So in the design environment like that, we created this part. If I wanted to add anything else onto this, we can do that all within the design environment here. So this is, as I said at the start of the presentation, this is like your SolidWorks of Fusion 360. You come in to do all your designing, whether you're designing a component or you're designing an assembly, it all can be done within this one environment. This part here, and again, you can bring in as much information into this environment as well. So if you wanted to maximize the most out of your machine and have everything, basically creating a digital twin of your shop floor or your machine, we can go along and we can add device into the environment. We can add the bed, the machine into the environment. We actually can import the machine into the environment as well and use the machine to simulate how the machine is going to run. So all of this is for crash detection and to be able to get the best out of your machine. So like that, I'm just going to switch these two off for now because we're just focusing on the part. So the first thing we look at is this part. So I'd spend a bit of time having a look at this part and seeing what's going on with it. A nice little feature within Fusion 360 is if I go up here to the inspect drop down, whether you're in the design environment or the manufacturing environment, it doesn't really matter. Over here in the inspect, we can do an accessibility analysis. So like that, if I was just given this part to machine, by doing an accessibility analysis, I can select the part. I can say what direction I'm going to be machining this in. So like that, my Z up, I'll select this line. So that is telling us that everything in green I will be able to do on the 3-axis machine. Everything in red I will not be able to hit if I'm just using the 3-axis machine. So we can see there's a hole there in from the side. I could not possibly do unless I had a 5-axis machine, or I'd have to do a second operation on my 3-axis to stand the part up. We can see there's an undercut here as well in red, and we see obviously the bottom of this is all in red as well. And we have 2 side holes here as well. So that is a nice little trick, just to be able to know that it's there to spot any undercuts, etc. We can see in the part. So this part, we can see most of it can be machined on a 3-axis machine. So again, I'm going to just cancel out my analysis. The other option here is a minimum radius analysis. So again, I want to just have a look at all the different radius inside. So again, by selecting that, it shows all the rads that are on this part. And we can actually see what size rad. So we can see there the minimum radius of 4.9. So that part, we can actually see what size holes, what size radiuses we are by just dragging this slider up and down. So if I wanted to see any sharp edges, I can select that, and we can see all the different sharp edges. So I know there's no little small fillets sitting down in any of these corners, etc. So again, 2 nice little tools to be able to use for our machining process. So let's go ahead and start machining this. So first thing I'm gonna do is create a setup. So when I create a setup, it's looking to tell me where's Z, where's Y, where's X. Because this part was actually machined on the XY plane, it actually was machined how it's going to be manufactured. So I don't actually need to play around with the X, Y, or Z because I want to machine this how I see it right now. If I did want to machine it up this way as my op 1, I'd manipulate these X, Y, Z's in order for them to Z pointing up, Y to point towards the back of the machine, and X to be pointing out towards the right hand side of the machine. So again, this is the way I'm going to machine it. This is the way I'm going to run it. That's the first thing, setting up your XYZ. The second thing is I want to tell it where my 000 position is. At the moment, it's right in the middle of the part on top of the stock. But I can select any of these little snowballs to tell it where I want my XYZ to be. So I'll just set it at the back corner on the top of the stock. If I go into my stock, if I go into my stock, I can come in here and I can actually, by removing the ones out of here, I can actually see what size, length by width by height this part actually is. So you can see there it's a funny length. It's 110 mil in the Y and it's 50 mil high. So I want to add material onto this. So I'm going to add 2 mil all the way around it. I'm going to add 1 mil on the top of it, maybe 8 mil on the bottom of it to grab it in the vise. And you can see it updates my stock dimension. So I may want to send this off to the purchasing department to be able to buy in 50 blocks this size. I can round up to the nearest also from inside here as well. So if I just press OK on that, we can see our setup is created. So we've set our XYZ direction, we've told it where 000 is, and we've given it a stock size, all in the space of a couple of seconds. So now I want to start running my tool paths on this. So we can see up here we have all our 2D profiles, 3D profiles. So all of these come with the base Fusion 360. The ones I'd point out here that don't come with it is your steep and shallow here, and your deburring option down in the bottom here. Again, Fusion has just added this deburring option in recently enough, and it's an awesome piece of kit, or an awesome function. So I want to run a face mill over the top of this. So I'm just going to select the facing profile. Brings me into the dialog box. I'm going to select a face mill. Again, Fusion has a huge library built, but you can create your own library of tools, and you can create all your different presets for different materials. So again, all the groundwork is done. So all you'd have to do is select a tool, and in the presets, if you have them all set, you can tell it if it's aluminium or plastic or steel, etc. So we just default that for now. So I've just given it a tool, and I'm just going to press OK. Before I press OK, we have loads of options here to do a lot of manipulation within this face mill. But for the easy part of this, I'm just going to press OK, and it runs a toolpath straight away for me. So now we're already cutting. We've already created some NC code. If I wanted to manipulate this toolpath, maybe I wanted to go from in, out, rather than left to right or right to left, we can do all of that within editing my toolpath over here in the browser. That's creating a face mill. I'm going to go and start roughing out some of this part. So I'm going to go for 2D adaptive clearing. The adaptive clearing is a nice strategy to save your tool length or your tool life. So I'm just going to select that 14 mil end mill. I'm going to select this guy and cut all the way around that. So for the sake of the demonstration, because that's a roughing strategy, if I was to simulate that, it will still show some stock left on because it's roughing. So if I go in and edit that, I can turn off stock to leave to nothing. So it'll just look like it's a finished part. And if I go and duplicate that, I'm going to edit the second one. I remove that. I'm going to select, this is my profile. Select contour, the bottom of the part is going to be this. And I want to go an extra 0.5 on that part. So I do apologize if my screen starts loading because I am powering through a webinar and I have a few things open, and Fusion is cloud-based. So when you're doing a webinar and using Fusion 360, it sometimes gets a wee bit sluggish for me. So if I was to simulate all of this, I'm just going to right click and simulate. So there's the stock material. And we can power this through. So there's the face mill, it's cutting off. You can see green is to size, blue means there's still material left on, and red means I've taken off too much material. So we can come in here and whip off all of this material. Speed this up a little bit. I'll actually go to the very end of the program. I can just bypass and not see what it's doing. So that's what we have at the moment. So we have a lot of this already nearly complete. I'd again use the pocket cycle. I'd duplicate this and maybe come in here and take out the pocket, but for the sake of demonstration, I won't do that. So one of the first strategies we want to have a look at is on the machine and extension is, again, as I said, if I was to do drilling, so you can see I have 4 holes here at the top and 4 counterbore holes down lower. So that would be, these are tapped holes. So that's a spot, a drill, and a tap, and then we have a counterbore. So spot, drill, and some type of an end mill to do the counterbore. So I'm going to go for a hole recognition, and you can see straight away it highlights the holes. So you can see it's going spot and the drill and the counterbore. And the second one here, it's recognized it's an M3 and it's going spot, drill, and tap these blind holes. So if I select them, you can see that they appear there. As I pointed out, if we're running on a 5-axis machine, I can come into the options here and go multi-axis, and now we can see that it's showing up this hole here, and it's showing up the 2 side holes here. So if I used to press OK on that, this is how fast the hole recognition tool works. There we have the spot, the drill, the spot, the drill, the tap, spot, drill, tap, etc., etc., etc. All done for us already. If I was to run a simulation on that, there might be a couple of little things to change. So you can see the length of that tool I'd have to update possibly. Spot drill, may have to update the length of that spot drill again. Again, when I say update the length, and this is all for crash detection. If I was to simulate this now, you probably have a couple of crashes because of the length of the spot drill. So let me just alter the length of this tool. So instead of editing the toolpad, I can come in here and I can mess around and inches. Lovely. Let me just go 6 inches, 3 inches, and 3 inches. Yes. So I'll have to regenerate that toolpath. And the other one was the counter bore. So again, I won't waste time. I'll just go and simulate this. We'll see the crashes, but we know how we can go about fixing the crashes. So again, if I want to speed through this, I'll just go to the tools. There's our 4 little crashes because that counterboard tool needs to be dragged out a little bit further. But you can see all the features are done for us. The tapped holes are shown up red because it is not recognizing them as a tapped hole, so that's why they're shown up red. Okay, so again, hole recognition, awesome function to have within the machine and extension. It's that quick. If I was to do that manually, I could be at it for half an hour, 45 minutes, as opposed to it took less than 2 or 3 minutes for us to be able to do that. And if you think about that across every part that you're working on, it's a huge time saver. So just for the sake of this, I'm going to just suppress the holes, and yes, just to turn them off for simulation while we look at the next one. So the next thing we want to look at is, we can see that there's a tapered angle or draft angle on this. What you'd do without the machine and extension is you'd probably use scallop or parallel or a combination of both. You'd use a ball nose and you'd end up just ball nosing all of this across. So again, which would take a huge amount of time. Or if you had a 5-axis machine, you might tilt your machine and run a facing profile here and a facing profile on all 4 edges, and then you do some type of a blend in on the edges of this. So with the machine extension, we get the ability of all of these options here as well. So if I went for a swarf and I pick a longer tool, let me grab something 80 mil, end mil. Let's go with this. I'm going to select contour, I want contour pair, so I want the bottom of the angle to the top of the angle. And again, huge amount of manipulation inside here as well. So I'm just going to press OK at that to just show how easy this is to use. And there we have the swarf angle. So if I was again to simulate this, and we'll just bypass the first couple of tools. Let's slow it down just so we can see what's going on. You can see that it tilts the tool. In order for us to get that. So again, when we have our 5-axis simultaneous machine, we can do all of this and use this extension for that too. Cool, so that's the swarf angle. And again, over here in the last little draft angle here, again, we'd probably use a parallel strategy. If we went for 2D pocket, I'll just use the 18 mil. Again, with the machine and extension, we get the option for tool orientation. So I could just use the tool orientation and select that's the orientation. You can see my axis slightly went parallel to that face, and I can just press. I have to give it a pocket, obviously. This is the pocket, and press OK. And there we have dash face complete as well. So this is that part complete. If I just go to the very end of this, did something wrong for me there on that last one. I probably went too deep on it, etc. So that's showcasing some of the extensions for a simple enough part like that. So the whole recognition is a brilliant time saver. Obviously, it reduces all the errors that you are going to have when you start writing programs for each and every strategy for spot drilling, tapping, and reaming, etc. And the swarf option here as well, again, is a brilliant one to have as part of the extension. So if we move into a more complex part, so here's a complex part. I'm not going to spend time writing the program for this. We have a face and the roughing of this already completed. So I want to focus in on this little surface area inside here. So traditionally, we would probably use the parallel option. I'm just going to select some type of ball nose, 5 mil ball nose. I want to highlight the sketch that I want to work on. This is what I want to focus on. Okay, so there's our parallel strategy. So you can see what a parallel does. It does quite a good job. Parallel is good for not steep surfaces. So when we're machining without the extension set, to do something like this, we do a combination of the parallel strategy, the scallop strategy, and the contour strategy. All three of them. We'd have all three strategies, and we'd combine them all together by doing parallel. And we might do some of the surfaces with parallel, and we'd give it an angle to notch, a threshold angle. So we may say don't go further than a 30-degree angle. So it'll complete all of the areas that are less than 30 degrees. Then we'd come in and we'd maybe do a scallop, and we'd go scallop would be the opposite. We do everything over 30, but not under 30 to be able to reduce that. And then we'd use the contour to kind of do a blend in between the two of them. So we don't have any blending issues. So you can see the parallel, it goes left to right or right to left, doesn't really matter, or it will go front to back, but it won't alternate from that. So that's your parallel strategy. Just to show you a little trick on Fusion 360. So if you spent a bit of time on any of these strategies and you decided actually maybe one of the other 3D strategies may have been better, rather than rewriting a whole new one, right clicking on the one that you just created and creating a derived operation is a nice way to kind of see what would look with a different strategy with all the same settings. So I go scallop and I just press OK. And it actually takes all the settings from the parallel and just applies them to a scallop. So you can see a scallop does a little bit of a better job. You can see there's some harsh turns inside here, which are going to leave little cusps. You can see it kind of runs its own path all the way around. So it does a decent job on it, but it's still not going to be great with all of these sharp corners. You're going to have blending issues where the cutter speeds up and slows down every single time it goes into one of these little corners. So if I was to right click on the scallop and do a create derived operation, 3D milling, and we look at a steep and shallow, and again I'm just going to press OK. So steep and shallow, it combines your parallel, scallop, and contour all into one. And with the manipulation that I spoke about earlier, is we can do a lot of different functions, or there's a lot more options inside here. So you can see the part looks a lot cleaner. We do have surfaces here that is wouldn't leave a nice finish because it's too wide. So we'd go in and we'd change all the different options inside in the steep and shallow. So if we went into the passes, we can see here that our threshold is 30 degrees. So that's to differentiate between what's a steep and what's a shallow pass. We can see the steep passes we've stepped down to 0.25, You can see the shallow passes are 1.27. That's why we're seeing big, massive gaps inside there. So if I was to rewrite and put 0.25 in for that one also, we can decide which type of a pass it's going to do for the shallow, whether it's a scallop or a parallel. We can do our climb mill and our conventional boat directions on that as well. If we go into the tool axis, we're going vertical. So if we did want to do some type of a tilt or a lead and lean, or if we created a point that we wanted that tool to always rotate around, we can do that also using the steep and shallow option as well. So without changing anything there, I can just press OK on that. Just give this a second. Always an issue when you're doing a live webinar. It just sometimes it just takes that a little bit longer. So you can see how much better this is. You can see that there's a lot of internal lines here. That's a blend. These are the blend lines. So again, within the options, we can tell it we want to have a blend of 2 mil or an overlap of 2 mil across one strategy to the other, all within the steep and shallow. So you can see this is doing a hell of a lot nicer finish. There's no sharp turns, meaning the cutter is always going to be maintain its speed. But to have this strategy alone, as I said at the start, as part of the extension, it's worth it for it on its own. So just jump away from the steep and shallow for a few minutes. We can come over here and modify, because you can see here that in the steep and shallow, we've got a lot of excess up here that we may not want to cut, because we've already ran a strategy on the top of this domed surface already. I can come up here to the modify, and all of these again are part of the extension, and I can actually trim. So if I wanted to trim there to there and there to there, and it's simple as that, just when I select OK. Now we can see that we've removed them tool paths from the top of that, and again we can trim out these sections as well. If I didn't want to come along the wall here, I can come along and start trimming out a lot of this. Again, going to save your machining time. So if you're machining a huge quantity, again, you want to try get every single second off that machining time. We can delete passes as well. So if I want to delete some of these passes that are out here that we think that there's too many of them, we can do that also. And it just updates that. And again, if we just wanted to take them seconds off the machining time, we're allowed to do our delete passes. Replacing a tool. So again, if you were to ever replace a tool within any of these strategies, you do know that it only takes a couple of seconds, but depending on the tool paths, like a heavy tool path like we see here, it could take 30 seconds for it to regenerate that tool path. We can change a tool that won't regenerate the tool path, it'll just do it very quickly. There's our move, exit, and entry positions. If we wanted to enter into this tool path at a certain location or exit out at a certain location, we have all of these available. So it's just before we go any further, I want to just run another quick little poll here. And I'm just going to launch this. So again, just kind of get an understanding of what the main manufacturing process is within your business. And we're nearly done with the webinar, so I'll just give people a heads up that there's not too long left, maybe another 5 or 7 minutes. We'll close out then. Just give it another couple of seconds. So we have a complete mix of areas. So I'm just going to close this and I can share that. So not too sure how that worked out. The milling was 100% and the rest was 55, 27, 45. That doesn't make sense to me. So we have a mixed bag. So just to highlight to everyone as well, like Fusion isn't just machine milling associated. up here in the, I'll hide that for a second. Up here, we are focused on the milling side of things today, but we do have the turning ability here as well. We've additive ability, we've inspection ability for probing and tool alignment or part alignment, and then we have fabrication as well. And there is a fabrication extension as well, so that if anybody does want to hear a little bit more about the fabrication extension, please feel free to reach out to myself. I'll have my email address at the end of this as well, and I can speak to you about that as well. To jump on to the next part of the demo, just again, the rest of this is fairly quick. I'm just going to kind of glide through it. So we have this part here that we would possibly machine. There we go. So if we have this on the bed and we want to go about machining this, the last thing we want to be doing is getting a big long tool sticking out of the holder, because it's going to be deflecting and vibrating, and we're going to have a really bad finish. So in order to be able to tackle this part, Fusion has the rotary strategy that would help us to do this. So the rotary strategy would be, it would look at the part if we have it on the 4 or 5 axis machine, and we can actually spin the part around in order to machine this. So if I was to simulate this, please work and don't crash. I should have turned off the chuck for this. So we can see how the part is rotating. So I do apologize about it. It's probably going to be jumpy on your screens because it's going through a webinar. But we can see how this is machining, as opposed to trying to get long cutters reaching out to be able to machine all of this. We can actually spin the part around to be able to machine it from the side, and it looks at all of these awkward details and is able to machine around the center point like so. We can even do angle the limits. So if there was just a certain area we wanted to machine, we can see here that we can run just certain areas using that rotary strategy also. That is kind of it. Obviously, there's a lot more to do with the extensions. I had the mudguard mold here as well, but that was just to kind of showcase a little bit on, again, what a parallel would look like if you were to run just your standard parallel, which does a decent job in certain areas, but a really bad job in other areas. We have our scallop, again, does a really good job, but surface finish won't be the best when you go to look at it, and you'd probably have cusps left in the areas as well, because, and you can see the sharp turns on the cutter where it's going to speed up and slow down, leaving machine lines on your part. And this then is your steep and shallow. So you can see the steep and shallow, it runs around, and you can even see this one has the cusp line inputted in the options as well. So it's actually going to go back over all the areas that it went around to take out them little last cusps. And again, the amount of manipulation you can do within this steep and shallow is just like, as I said, trying to, and I've done it myself, that when I'm machining awkward or complex geometry like so, I'd use the parallel, and I'd use the scallop, and use the contour, and I'd spend hours trying to manipulate all three of them, that they're not going to be cutting fresh air, they're not going to be overlapping too much, and they're all going to be able to have a nice little bit of a blending. That steep and shallow will do all of that work for you without having to manipulate 3 different strategies and combine them all together and making sure that they're all interlinked. That steep and shallow will do all that heavy work for you. So if I jump back to my PowerPoint, sorry, I was going to show one last trick, because I did say I was going to show you a few tricks. If you were running, and again, you probably know all of this. So if I was to right click on a few of these, sorry, shift and select 3 of my tool paths, and I right click, I can store these as a template. So my face, my additive. So let's just say it was a face, roughing, and a finishing contour. I can store these as a template because they'd be similar on most parts that you're going to be machining. When you store it as a template and you create your setup, if you right click on your setup, we can create from a template, and you can select your template, meaning it's going to apply them 3 tool paths onto your new part or your new setup. All you'll have to do is go in and maybe reselect the new contours, because every part is different, obviously. But again, it's a nice little trick. People don't know about it. Storing your so you're putting a lot of time into maybe a parallel or even a steep and shallow. You want to save that steep and shallow, so you just right click on it, store your template, and then that steep and shallow you can apply it on your next part and your next part and your next part, because you put the time and effort into getting it perfect on your model. So you want to keep all of them settings and apply them to the next part, etc. So that, again, right click on the setup and create from a template, and just drop the template. If I do the, I'm not too sure what the milling ops is. So you can see it added facing, additive or adaptive to pocket, and the contour fairly quickly straight in there. And then all I have to do is right click and manipulate. The tool is set up, your step overs is set up, your direction is set up, your lead in, lead out is set up. So it's all done and dusted. So again, another huge time saving trick that comes free with basic Fusion 360. So again, just to jump back into the PowerPoint before we finish up, I'm just going to run one more poll here. So again, just trying to get a good understanding of our audience today. Give that another couple of seconds. Again, I'm going to have my email address flash up there on the next slide. So you can reach out to me if you have any questions relating to the machining extension or any of the extensions, or even just Fusion 360. So I would be the Fusion 360 expert within Symmetry Ireland. So all Fusion 360 queries come my direction, and I end up solving them or helping with them. So feel free to reach out to me at any point. Just to give you an understanding on Fusion 360 and the extension as well. So the extension you can actually, so it's not like a Sky TV where you purchase it and you have it for the year. It's more of a, you can purchase it, actually Sky's never changed like that. So anyway, you can purchase it and turn it on for a month. So if you only need the extension for a month and you're not going to be using it for another 3 months, etc., you can do it that way as well. The extension costs for the annually, I think it's in and around 1,500 plus or minus whatever, maybe 100 or so. So I'm not saying, so I think that's the price point is in and around the 1,500. For Fusion base, it's just 500. So to get the base and the machine extension is still under your $2,000 or in around the $2,000 mark, which is still incredibly cost effective. It's incredibly cheaper than other softwares out there, let's say, that would do the same task. But most softwares, they either fully focus on machining or fully focus on design, and that's the beauty of Fusion. It combines both of them. So I'm just going to close that both there, and I'll just share that. So again, thanks for everyone for voting on today's polls. That's the end of the polls. I'm just going to jump to the last slide here. There's my email address. So again, if you have any questions or queries, feel free to reach out to myself, and I'll get back to you. So thanks again for everyone joining today. Don't think I've left out anything. So yeah, we leave it at that. Thanks again.